Hello, welcome to today's tutorial. Today we're going to talk about the triangular perforations with curved attractors to influence this pattern. Okay, let's start. So the first step, we're going to create a triangle grid. The size for each triangle will be 100 mil. Extend in X direction, we give it 100. And then we have another 50 triangles from the Y direction. The next step, we're going to use a scale battery. We connect the cells to geometry, and then also we need to make sure the center of this scaling is the center of each triangles. And then we can give it a scaling sort of factor to affect the size of the triangle perforations. And then we can use the method that we introduced in tutorial 1 to create consistent changing patterns from bottom to top. So I'll just quickly run it here. If you want to understand logic in it, please listen to tutorial 1. Then we connect that 50 to count. We can use 1 to divide the count, and then use minus, then we minus 1. Then connect back here. We have 0 to 1. Then we use a graph mapper here. We choose Bezier. The output, we give it to 0.5 to 0.9. And then we connect it back to our vectors. Now you can see consistent changing perforations. And then we can control the graph mapper to control the gradient. And today we're going to talk about another method to create patterns, which is using a curve to control the patterns. So first we draw a curve in Rhino, and then we use curve battery to catch it into the grasshopper. And then the next step is to actually use this curve to influence our triangle sizes. How to do it is actually by finding the distance between each triangle to the curve that we just created. The way to do it is we find the curve closest point, and then we have all the center. I'll turn it on. All the center of the triangles. We find the closest point on this curve to the point of triangles. Then once we find that closest point, we can measure the distance between the closest point and the point, and then we actually get the distance between that point to that curve. So that's the logic in it. So if we connect the curve to here, connect the centroid to the points, and then we measure the distance between the points we just used to the closest point on the curve. Then we got the distance between each single triangle center to the curve. And let's turn these off. Once you find it, we can use remap. So at first, let's view the data or distance that we got. So you can see all the distance different. So now we want to use this distance as an influencer to influence the scaling factor. So we're using remap. So we remap all this distance to a 0 to 1 to connect that distance to value. We use a bound domain connected to source, and then target will be by default 0 to 1. So we now translate all the distance to a mapped new value, which is from 0 to 1. And then we use graph mapper again. Again, we're using Bezier. Is connect the mapped to the input. Input will still be 0 to 1, and then the output we give it 0.5 to 0.9, and then we connect it back to our scale battery. Now you can see the pattern is actually influenced by the curve. So the triangle is closer to that curve, get scaled harder and become smaller. And then we can actually change, make sure you click this gumball, and then you can use the gumball to quickly change the shape of the curve. So by changing the shape of the curve, we're actually changing the perforation pattern. And then we can also use this graph mapper again to change this variation size. But the thing is, every single triangles now is influenced by that curve. So if we want, for example, only the triangles closer to that curve get influenced, the others remain what it is, we need to split the whole triangle pattern into two parts, the parts that close to the curve and then the parts that far from the curve. So how to do that is we need to find the triangles that is close to that the curve. So the battery we're going to use called sort list. So we sort the distance, and then we use the distance as a reference to sort our cells. And then let's turn this off first. And then we can use split list. When we choose index 20, that means the 20 triangles that closer to that curve will be influenced. So the list will be the sorted triangle list, which is here. And then we can turn this off, and then the list A, we can see that triangles that closer to the curve got selected. And then we can directly use another split list to split the distance we've got here. And then we connect the geometry. Let's lock the solver first, just to stop it running. And then we connect the geometry to the scale here, the scale geometry here. We find the center of all this geometry, connect the center to center, and then we use the value that we've got for these triangles only, and then connect it to value, and then we take that lock solver to make it run again. preview off, we turn this on. And now you can see only the triangles that closer to that curve got affected. We can right click the graph mapper, choose revise. So now you can see the 20 points, 20 triangles that closer to that curve got influenced. So you can change that, easily change that value. And also we're going to show the other triangles, which is here. We can scale it a bit as well. We connect that to geometry, connect that to center, and then the factor, give it 0.9. We turn all this off again. And then we can use this graph mapper to adjust the pattern. We can also use the split index to choose the extent of the scaling until we get something that we feel good. At the moment, the pattern are just curves, so we can actually use boundary surface to create surface. Make sure we simplify the data, and then we merge the triangles with the scale triangle together. And then we do the same to the other part. I want to change that, change the shape of the curve again as well, just to make it look better. I want to change the value to 0.5 to 0.8, probably 0.2 to 0.8. Changing that to 0.8 as well. And now we can use boundary surface. We need to flatten it first. Then graph it. So in that way, we create a new type of data. So now you can see we have 2400 branches, and each branch we have 2 values. Then connect it. We're doing the same thing to the other one. Connect it here. If we hide the curve, then we can simply back it out. Then we change the material a bit to a different color. Then we rotate, and then we can visualize it. And that's today's tutorial. Thanks for watching today's tutorial. Please subscribe to support and check out my other videos.